minus. 1 minus because it's got to cancel out the 1 plus charge that we get from the 1H plus. Okay, so the negative ion that we're going to be working with here is Br minus. We take a look at this chart. Br minus, we call it bromide. So to name this acid that has bromide in it, we're going to follow these rules. We take the IDE off, we take the stem, BROM, and we stick it between hydro and ic. So we're going to get hydro, brom, ic, acid, hydrobromic acid. So that's how we name these acids without oxygen, where the negative ion ends in IDE. Now let's take a look at how we name acids that have oxygen in them. In acids with oxygen, the negative ions are...
Okay. For the first part, remember, we need to take a look at the negative ion. Well, in all of them, that's what you have to do, taking a look to the negative ion. So I want us to practice a little bit more. So this table that you see over there, the table of the negative ions, please write it down in your notebook right now in this moment. I'm giving you 1 minute to do that. Did you finish? Did you finish to write it down? The table of the negative ions. Okay. Now take a look to this. We're going to practice with 2 more examples. Okay? So take a look to this first acid. I know it's an acid because it has hydrogen in the left side of the reaction. Of the compound. So how is this acid made of? We need to break it down into its ions, okay? Remember, one ion is going to be hydrogen. Mandatory that one ion must be hydrogen. And the other ion is I. What is the charge that we use for I? I is iodine. Remember the table that I gave you in the beginning, okay? In this table, I gave you some elements, the non-metals, and I gave you the charges for each non-metal, okay? So every time you see a binary acid, this is the charge that you have to use. Now let's focus on the element iodine, okay? Iodine has a charge of -1. So we go back to this and we write the charge above. Now, remember, this is known as iodine. According to Tyler's table, the name of the element is iodine, okay? But the ion is known as iodide. So according to the procedure that he taught us, he says that we need to get rid of the suffix and put it between hydro, ic, and then complete it with the word acid, okay? So you take the stem, you take the root is IOD, so the final name will be hydroiodic acid. Hydroiodic acid. Hydroiodic acid. Like that. Because I'm the one who did it, I'm gonna write one more example for you. Maybe this time you participate. How would you name this acid? Okay, how would you name it? Remember, the first step that we do is we break it down into its ions. One ion is H plus and the other ion is F. What is the charge for F?
Fluoride.
Yeah, the name is fluoride. But what is the charge?
Negative.
Negative or just -1, okay? So, according to the rule, we get rid of the suffix IDE and we put it in between hydroic acid. So the total name will be hydrofluoric acid. Hydrofluoric acid. One more time, you need to participate a little bit more. Another example. Remember, I need to break it down into its ions. I have H plus and I have N. What is the charge for N?
Negative. At -3.
-3. How do you call N?
Nitrate.
Nitride. Nitrate is NO3. You need to be careful on that. Nitride. So how will be the name? How is going to be the name?
Hydronitric acid.
Hydronitric. That is correct. Remember, the root is hydronitric. Okay, nitric. Now, there are some elements that have a special root. Remember that I gave you a list of elements that have a special root. Now, for acids, the root changes. Okay, for sulfur, the root of sulfur will be the entire name, so it's going to be sulfur. For phosphorus, it's going to be phosphor. For carbon will be the entire name, which is carbon, and for nitrogen, the same as I explained you before. Wait. Okay, so for nitrogen, this is the same root that I gave you before, and it is the root that we used. Okay, nitrate and nitrate. Now, knowing this, knowing the special roots, how can us be naming this compound right here? The composition of this acid is hydrogen plus ions and S. What is the charge that we use for S?
-2.
So what will be the name for this compound?
Hydrosulfide. sulfuric acid.
That is perfect. Hydrosulfuric. Hydrosulfuric acid. Remember, here the root changes. For acids, there are some exceptions, okay? That's why I gave it to you here. Now the last one, how can we name this one? The composition of this acid is H plus ion. How many hydrogen ions?
Just one.
What about the substrate?
3.
Negative 3.
3 H plus ions. So we say that we have 3 atoms of hydrogen which has a charge of positive 1. Now, about phosphorus. What is the charge for phosphorus? It is in the table. What is the charge of phosphorus?
Negative 3.
Negative 3. So here we have how many phosphorus? Here it's invisible 1. Okay? So in other words, this is telling me that I have invisible 1 amount of phosphorus. Okay? So if you need to get it, will be 1 times negative 3. The charges must be balanced, which means that they must have the same number but with different sign. 3 times 1 gives me 3, and 3 times negative 1, 1 times negative 3, is going to give me negative 3. With this, we make sure that the formula is balanced, okay? That the formula makes sense. Now, how do we call P3 minus? How do we call P3 minus? It is in the table.
Phosphide.
Phosphide. Okay, the name for this acid is going to be then what is going to be the root for phosphide?
Hydrophosphoric acid.
Exactly. I gave you the special root that whenever you have phosphorus, the root is going to be phosphor. Okay, phosphor. So this is going to be, in the end, hydrophosphoric acid. Very good. Remember, this trick is only when you have 2 elements acids. Now let's talk about the rest, okay?
Negative ion ends in IDE. Now let's take a look at how negative ions are polyatomic ions like these.
The other kind of acids are known as oxyacids, or like he wrote over there, oxoacids. The way I was taught was oxyacids. And for this one, you're gonna need polyatomic ions, but only those polyatomic ions that have oxygen, like the list that he is showing you right there. Sorry.
That have oxygen combined with other elements. And that group of elements together has a charge. These polyatomic ions end in ATE and ITE, ate and ite. And these endings are what we're going to be looking at when we name acids that contain these polyatomic ions.
So the key for naming oxyacids is taking a look to the suffix of the polyatomic ion. You're going to have only 2 possibilities. The suffix ate, like carbonate, and the suffix ite, like chromite. That is going to define how you're going to be naming the acid.
Now, it's really important to be able to recognize the polyatomic ions so you know what to call them when you run into them. I'm going to be using this chart in the video, but I recommend that you memorize a whole bunch of the polyatomic ions. Hopefully your teacher can suggest a list for you to learn so that you'll be able to do problems like these. As we move ahead, here's just a little review of what we did previously. So here's our first acid with oxygen that we're going to name, HNO3. We're going to break this up.
For every acid, I thoroughly recommend to break it down into its ions. Remember, one ion is going to be hydrogen, and the remaining is going to be the anion. So what is the anion that you recognize in that acid? What is the name of NO3? Take a look at the table. I gave you 4 tables, remember? So look for NO3 and look for the name. Did you find it?
Nitrate.
Nitrate. Remember, we take a look at the suffix ate, nitrate. Now take a look.
Into the ions that make it up. And the negative charge here, the 1 minus, balances out the 1 plus on the hydrogen. Now, this NO3 is the negative ion that we're working with, so what's its name? It's a polyatomic ion, so I'm going to look at my list of polyatomic ions. This polyatomic ion is called nitrate. So that means that I'm going to be using this rule for naming the acid.
Take a look to that rule. It says that if the negative ion ends in ate, you will replace it by the suffix -ic and the word acid. So the name will be, instead of nitrate, replace the ate by -ic.
If the negative ion ends in ate, we take off the ate and we add an IC. So I'm going to go from nitrate here to nitric acid. 8 to -ic. Let's do another example. Here we have H2.
How would you name that compound? CO3. What is the name of that polyatomic ion?
Carbonate.
Carbonate. So, if we have carbonate, we're going to replace carbonate, we're going to replace ate by the suffix -ic, okay? So it's gonna be carbonic acid. As simple as that, okay? Just take a look to the suffix. If it's ate, replace it by -ic. Then just add the word acid.
CO3. We're going to break this 2 minus.
Break it down,
okay? And CO3 2 minus is carbonate. I got that right here, so I don't have to write it in. Carbonate. So now using these rules, the name of the ion ends in ate. So I'm going to take off that ate. I'm going to replace it with IC. So I'm going to call this carbon, and then IC, carbonic acid.
You see, not too complex in the end. Just replace the suffix by the suffix -ic. Now, this one, you will notice that it's made of hydrogen and nitrate.
And the rules that we
NO2 is nitrite. It ends in ITE. So for the suffix ITE, there's another rule.
Used to name these are that if it ends in ITE, you remove the ITE and then you put OUS acid. So we go from nitrite to nitrous acid. So nitrous acid is what we call the acid that contains nitrite as its negative ion. Here's one more example of how we do this naming with ITE. We have this acid here. We break it apart into H+, and then everything else, which is going to be CrO2 2 with a 1 minus charge to balance out the 1 plus charge. The name of this negative ion here, CrO2 1 minus, is chromite, which means that the name of the acid.
What would be the name of the acid if it ends in ITE? Instead of chromite, it's gonna be the acid
Chromic acid.
If it ends in ITE, you have to replace it by O's.
Chromous acid.
Chromous acid. Chromous acid.
I replace it with OUS, and then I add acid. So it has chromite in it. We call it chromous acid. So these are the rules for naming
And that's a mnemonic. That's a mnemonic to remember the rules.
Acids based on the name of the negative ion that's in that acid. How are you going to remember them? Here is a great mnemonic that I really like, okay? My ride has hydraulics. This isn't actually how we spell hydraulics, but, you know, whatever. So IDE, hydroic, so that's how you name this type of acid. And then I ate something icky, because acids that contain ions with ATE at the end are named with IC, okay? And then finally, Sprite, ITE, is delicious, OUS. So remember these 3 sentences. You'll never ever have a problem with naming acids. I love this. It's great, particularly this with a ride that has hydraulics. It might be a Lamona GXL. I don't know. I want to talk about some important exceptions.
And there he's going to talk about the exceptions that I already gave you, okay? The root for phosphorus and the root for sulfur, okay? It applies in the same way for the negative ions. So for phosphate, the root is going to be phosphor, and because it ends in ATE, it's gonna be phosphoric. Take a look.
With naming acids, we looked at they actually turn out to be contain the negative. We took this from phosphate into ic, and so we call it phosphic acid.
Phosphoric acid will be your first guess, probably. But if you already know that it is an exception, you have to use the root I gave you.
Phoric acid. You have to add this OR before the IC. I have no idea why it's like that, but I just want to let you know, because if you were being very logical about it and follow the rules that we've learned, you'd actually be wrong. So I just want to make sure that you know how to name this acid. And similarly, this...
How would you name phosphite?